I welcome you all in this practical lecture of pharmacology and toxicology. So today we will conduct the experiment number 12. So aim of this experiment is to interpret from the graph by observing the effect of spasmogens and relaxants on the intestine of rabbit by using the CD of MSBT. Okay. So spasmogens are the agent which causes the contraction of that smooth muscles, okay, or that muscles, and relaxants are the agent which causes the relaxation of that muscles, okay. Then we must see the effect of such agents on the rabbit intestine in this experiment.
Aim of this experiment is effect of spasmogens and relaxants on rabbit intestine. The objectives of this experiment are to understand the terms spasmogens, spasmodics, spasmogenic and antispasmodics or spasmolytic or spasm relaxants, to understand the phenomena of peristalsis, to understand the terms tonic spasms, atony, cramp.
Requirement for this experiment is animal, rabbit, physiological salt solution, thyroid solution, drug, acetylcholine 1 mg per ml, instruments and equipment, Sherrington's rotating drum, student's organ bath, aeration tube, aerator, frontal writing lever, stand, clamps, plasticine wax.
Spasm is characterized by sudden and involuntary increase in constriction of smooth muscles. Spasmogens are agents which initiate muscle spasm. Relaxants are agents which decrease the tone of smooth muscles. In intestine, presence of food triggers neural and central parasympathetic reflexes, causing contraction resulting onward movement of food bolus.
Okay, so here it is two concepts are clear. What is meant by spasmogen and what is meant by relaxants. Okay, so spasm, it is nothing but the sudden or involuntary increase in contraction of smooth muscles. Okay, so sudden or involuntary increase into the contraction of smooth muscles, that condition is known as spasm, and the agent which causes such a spasm or initiates such a spasm are known as spasmogens. Okay, and relaxants are the agent which decrease the tone of smooth muscles. They causes the relaxation of that smooth muscles. Okay, so generally in intestine, the presence of foods that triggers the neural and central parasympathetic reflexes. Okay, so when we administer some food, it causes the triggering of nerve impulses of, or which causes the stimulation of parasympathetic nervous system. Okay, and this results into a contraction that results in the onward movement of food bolus. Okay, that is peristalsis movement into the intestinal region.
Obstruction in intestinal lumen is painful and results in cramp known as colic. Loss of peristalsis is known as atony of intestine. Spasmodics initiate smooth muscle contractions and restore peristalsis. Smooth muscle relaxants like papaverine and adrenaline reduce tone, force of contractility and induces relaxation. Acetylcholine increases tone and force of contraction of smooth muscles of intestine through muscarinic receptor and is spasmogenic in action. Atropine-like parasympatholytics nullifies spasmogenic effect of acetylcholine on muscarinic receptor and acts as spasmolytic.
So obstruction in the intestinal lumen is painful and that results into a cramp which is known as colic. Okay, so peristalsis movement मध्ये जे काही ऑब्स्ट्रक्शन येतात की ज्याच्यामुळे पेन अराइज होतं त्याला क्रॅम्प असं म्हणतो आणि त्याला आपण असं कोलिक सुद्धा म्हणू शकतो. ओके, and loss of peristalsis, that state is known as atony of intestine. Okay, so peristalsis movement जी आहे नॉर्मल इंटेस्टाइनची ती जी मूवमेंट लॉस होते त्याला आपण atony of intestine असं म्हणतो. ओके, so spasmodics कॅटेगरीचे जे ड्रग्ज आहेत which causes the contraction, okay, that initiates the smooth muscle contraction and thereby they restore the peristalsis movement. ओके, मग कोलिक कंडिशन्स मध्ये किंवा क्रॅम्प कंडिशन्स मध्ये किंवा atony मध्ये जी पेरिस्टाल्सिस मूवमेंट मध्ये ऑब्स्ट्रक्शन आलेले असतात ते इनिशिएट करायचं काम स्पाझमोडिक कॅटेगरीचे ड्रग करतात. ओके, smooth muscles relaxants like papaverine, adrenaline, which reduces the tone, force of contractility and induces relaxation. Okay, मग रिलॅक्संट्स जे आहेत मसल रिलॅक्संट्स कॅटेगरीचे जे ड्रग आहेत त्याच्यामध्ये पपावेरिन आहे, ॲड्रेनालिन आहे. सो हे ड्रग काय इफेक्ट शो करतात, दे रिड्युसेस द टोन अँड फोर्स ऑफ कॉन्ट्रॅक्टिलिटी अँड देअर बाय दे कॉजेस द रिलॅक्सेशन ऑफ दॅट इंटेस्टिनल ट्रॅक्ट. ओके, ॲसिटाइलकोलिन कॅटेगरीचा जो ड्रग आहे विच इन्क्रीजेस द टोन अँड फोर्स ऑफ कॉन्ट्रॅक्शन ऑफ स्मूथ मसल्स. ॲड्रेनालिन टोन आणि कॉन्ट्रॅक्टिलिटी डिक्रीज करणार आहे स्मूथ मसल्सची. ॲसिटाइलकोलिन इन्क्रीजेस द टोन अँड कॉन्ट्रॅक्शन of smooth muscles of intestine. So by acting on the muscarinic receptor it causes the spasmogenic action. Okay, so spasmogenic action म्हणजे काय, it causes the contraction of smooth muscles present on the intestinal region. Okay, then atropine like drug आहे which causes the parasympathetic effect. Okay, so parasympathetic effect possess करतो म्हणजे काय करतो, तर पॅरासिम्पॅथोमायमॅटिक जे ड्रग आहेत त्यांच्या अपोजिट इफेक्ट शो करणार आहेत. ओके, पॅरासिम्पॅथोमायमॅटिक ड्रग कोणता आहे, ॲसिटाइलकोलिन. मग ॲट्रोपिन इट शोज द अपोजिट इफेक्ट टू दॅट ऑफ ॲसिटाइलकोलिन. ॲसिटाइलकोलिनच्या अपोजिट इफेक्ट ॲट्रोपिन शो करणार आहे. ॲसिटाइलकोलिन स्पाझमोजेनिक इफेक्ट शो करतो, मीन्स इट कॉजेस द कॉन्ट्रॅक्शन ऑफ स्मूथ मसल्स ऑफ इंटेस्टाईन. सो हा जो इफेक्ट आहे तो नलिफाय करायचं काम ॲट्रोपिन कॅटेगरीचा ड्रग करणार आहे. ओके, so this atropine like parasympathetic which nullify the spasmogenic effect of acetylcholine on the muscarinic receptors. Okay, and thereby it act as an spasmolytic drug. Okay, so acetylcholine is a spasmogenic drug and atropine it is an spasmolytic drug. It produces opposite effect to that of acetylcholine, means it causes the nullify the effect of acetylcholine. Okay, so this action is exerted by the atropine drug. Adrenaline which causes the relaxant effect on the smooth muscles of intestine, acetylcholine which causes the contraction of smooth muscle of intestine, and atropine which nullify the effect of acetylcholine, means it causes the spasmolytic effect. Okay, so these are the three drugs which exerts the different effects on the smooth muscles of the intestinal wall. So here it is the procedure.
To study the effect of spasmogens and relaxants on rapid intestine, isolate the jejunum of small intestine. Clean the contents of jejunum with thyroid solution in a syringe. Avoid any damage to smooth muscle lining of jejunum. Take a piece of jejunum about 2 to 3 centimeter long. Ensure the lumen of the jejunum is clean and open. Tie the thread to the top and bottom ends of the jejunum loosely. Ensure lumen remains open. Now, mount the preparation in organ bath containing thyroid solution. Maintain the temperature of water bath at 37 degrees centigrade. Aerate the muscle preparation with aerator. Now stabilize the muscle preparation for 30 minutes under a tension of 0.5 to 1 gram. During stabilization, wash it with fresh quantity of thyroid solution for at least 4 times. Now, start the drum. You will observe the intestine shows pendular rhythmic movements under normal conditions evident from the pattern of tracings. Now inject 0.1 ml of stock solution of acetylcholine in the reservoir. Record the contractions for 30 seconds. You will observe upward movement of tip of the frontal writing lever. This indicates increase in tone and contractility of the preparation. Therefore, we can say acetylcholine shows spasmogenic action. Allow the preparation to relax by rapidly washing with fresh quantity of thyroid solution to wear off the effect of acetylcholine. Record normal pendular movements. Now inject 0.1 ml of stock solution of barium chloride and record the response. You will observe increase in tone and force of contraction as evident in the tracings. Therefore, we can say barium chloride also shows spasmogenic action. Allow the preparation to relax by washing with fresh quantity of thyroid solution to wear off effect of barium chloride. Record normal pendular movements once again. Now inject 0.1 ml stock solution of atropine followed by 0.1 ml stock solution of acetylcholine. Record the response for 1 minute. You will see the preparation shows normal pendular movements. This indicates acetylcholine in the presence of atropine doesn't show any change in normal pendular activity. Therefore, we can say atropine nullifies spasmogenic effect of acetylcholine and acts as antagonist of acetylcholine. Relax the tissue properly and record normal pendular movements. Now inject 0.1 ml stock solution of adrenaline. Record the response. You will observe the preparation is now relaxed, evident from the reduced tone and force of contractility. Hence, one can say adrenaline acts as smooth muscle relaxant.
Okay, so in that procedure we had used 4 drugs: acetylcholine, barium chloride, atropine and adrenaline. Okay, so among those, acetylcholine and barium chloride, which possess the similar action, that is they act as an spasmogenic drug. They causes the contraction of smooth muscles, right? Then adrenaline, it acts as an relaxant. Adrenaline causes the relaxation of smooth muscles. Okay, and atropine, in presence of acetylcholine, it acts as an spasmolytic. Okay, मग जेव्हा acetylcholine आणि atropine एकत्र दिलं गेलं तेव्हा atropine it acts as an antagonist of acetylcholine. Okay, means it opposes or nullifies the effect of acetylcholine and thereby it acts as an spasmolytic drug. Okay, means acetylcholine मुळे जे spasmogenic effect शो होत होता तो इफेक्ट ब्रेक करायचं काम हा atropine ने केलेला आहे, म्हणून atropine ला इथे spasmolytic drug असं म्हटलेलं आहे. ओके, now we will see the observation table. So here it is, the observation table. First is when we inject the acetylcholine drug, what is the response we get? So this is the graph that indicates. So इथे तुम्हाला दिसते this is the normal pendular movement, and when acetylcholine get injected, the peak height is get increases. That is, it shows the stimulated response, that is increase into the height of that peak. Okay, due to the contraction of that smooth muscles. When we inject the barium chloride, same effect is shown. Okay, so normal pendular movement when we inject the barium chloride drug, it shows the stimulated response. It means acetylcholine and barium chloride causes the contraction of smooth muscles. Okay. Then when we inject the atropine and acetylcholine togetherly, okay, when each 0.1 ml dose get injected, so you have seen here the normal pendular movement get continued. Okay, so the effect of acetylcholine get nullified by the atropine. Okay, so therefore the normal pendular movement get maintained. Then if we inject the adrenaline drug, so you have seen here this is the normal pendular movement and here is the relaxation of that particular smooth muscles. Okay, so response we get is relaxed of that smooth muscles. Okay,
You have learned that cholinergics are spasmogenic and anticholinergics are antispasmodic. Sympathomimetics or adrenergics are smooth muscle relaxants.
so by observation what we have concluded, acetylcholine which causes the contraction of intestinal smooth muscles of rabbit, right, and atropine administered with acetylcholine they produces the spasmolytic effect. Okay, and when the adrenaline get administered it causes the relaxation of smooth muscles of intestine of that rabbit. Okay, so these are the effect exerted by the certain kind of spasmogenic and spasmolytic and relaxants drug. Okay, so here it is the finish of this experiment. So thank you.